The cosmos has always called to us. Since the dawn of humanity, we've gazed up at the stars, wondering what lies beyond our world. The night sky has inspired myths, dreams, and a relentless curiosity to explore the unknown. For decades, space was a contest between two giants, the United States and the Soviet Union. Their rivalry defined an era, as each nation poured resources and ingenuity into reaching farther and faster than the other. Their competition, the original space race, was about more than just technology. It was a battle for national pride, a demonstration of power, and a way to prove which system would lead the future. Every launch was a global event, watched by millions. Each astronaut became a symbol of hope, ambition, and the limitless potential of humanity. The ultimate goal was clear: plant a flag on the moon, showcase your nation's prowess, and claim dominance over the high frontier. The world held its breath as humans set foot on another world for the first time. The technology was groundbreaking, pushing the boundaries of what was thought possible. But access to space was tightly controlled. Only the most powerful governments could participate in this cosmic quest. The rest of the world could only watch from the sidelines, dreaming of a day when space might be open to all. But today, the story is different. The landscape of space exploration has shifted dramatically in just a few decades. The new space race is no longer just about nations. It's about visionaries, entrepreneurs, and private companies who dare to dream bigger and move faster. SpaceX, led by Elon Musk, has shattered old assumptions about who can reach space. Their bold approach has inspired a new generation to believe that the stars are within reach. Now, it's a contest of innovation and accessibility. Reusable rockets, once thought impossible, have become a reality, dramatically reducing the cost of reaching orbit. The goal has evolved, not just to visit space, but to live and work there. We're building the foundations for a future where humans are not just visitors, but residents of the cosmos. Reusable rockets have slashed costs, opening the door for more science, more exploration, and more opportunity than ever before. Suddenly, space is within reach for startups, universities, and even individuals. The competition is no longer just about flags and footprints. It's about building the infrastructure that will support humanity's long-term survival. Satellite networks, space habitats, and the technology to reach new worlds. Boeing, the legacy giant, faces off against SpaceX, the bold disruptor. Their rivalry is shaping the future of human spaceflight, pushing both to innovate and adapt. Their battle is for the future direction of humanity's expansion into the cosmos. Will we become a multi-planetary species, or remain bound to Earth? Who will build the ships that carry us to Mars and beyond? Who will design the habitats where future generations will be born and raised among the stars? Who will control the networks that connect our planet, enabling global communication and unlocking new possibilities for science, business, and society? The answers are being written now, launch by launch, as a new era of exploration unfolds. The journey from nations to nomads has begun, and the next chapter of humanity's story is being written in the stars. In this new space era, the battlefield has expanded far beyond the ground, sea, and air. Now, the silent expanse above us has become a critical domain where the balance of power is constantly shifting. National security is more critical than ever as nations race to secure their interests in orbit. Every second, military analysts and operators monitor the skies, tracking potential threats and safeguarding vital assets. The US military depends on a vast network of satellites for communication, navigation, surveillance, and early warning systems. These satellites are the invisible backbone of modern defense, enabling everything from troop movements to missile detection. Losing access to this orbital high ground is not an option. A single compromised satellite could jeopardize entire missions or even national security itself. Boeing, with its deep government ties and decades of aerospace expertise, remains a key player in this high-stakes arena. Their latest contract is ambitious, a new constellation of advanced, secure communication satellites designed to withstand the most sophisticated threats. These satellites are engineered to resist jamming, hacking, and cyberattacks, ensuring that military communications stay open and secure, even in the midst of crisis or conflict. Modern warfare now extends to space and cyberspace, where invisible battles are fought over data, signals, and control. Disabling satellites could blind a military, disrupt global communications, and even cripple economies that rely on GPS and data networks. Boeing systems feature advanced encryption, multiple layers of redundancy, and the ability to maneuver in orbit to avoid threats, making them resilient against both physical and digital attacks. While SpaceX pushes rapid innovation and commercial access to space, Boeing delivers proven, mission-critical reliability that the military can trust in the most demanding situations. The military needs technology that simply cannot fail, systems that are tested, hardened, and ready for the unexpected. Boeing's legacy in defense, built over generations, gives it unique credibility and a deep understanding of what's at stake. In the new space war, SpaceX leads the charge in commercial launches, but Boeing stands as the guardian of national security in orbit, ensuring America's eyes and ears remain open. The stakes have never been higher. In this era of uncertainty, the race for space dominance is not just about technology, it's about securing the future. While Boeing secures the skies with its decades of experience in aviation and aerospace, building some of the world's most reliable aircraft and rockets, SpaceX is taking a bold leap forward, revolutionizing how rockets are designed, built, and launched. Their rocket factory isn't just a place of assembly, it's a hub of innovation, where the future of space travel is being shaped every day. To truly become a multi-planetary species, humanity needs rockets that can be built as efficiently and reliably as cars rolling off an assembly line. This means rethinking every step of the process, from raw materials to finished launch vehicles. Enter the Starship Block 3 booster, a technological leap not just in performance, but in manufacturability. It's designed from the ground up to be easier, faster, and cheaper to build. Earlier versions of Starship were intricate, experimental prototypes, each one a learning experience. Block 3, however, is the result of countless lessons learned, now streamlined for true mass production. By using standardized parts and modular systems, SpaceX can assemble rockets much faster and at a fraction of the previous cost. This approach also makes repairs and upgrades far simpler, paving the way for rapid iteration. The goal is ambitious. SpaceX aims to produce a brand new super heavy booster every few days, turning rocket building into a high-speed, high-volume process never before seen in the industry. This unprecedented scale is essential for Mars colonization. We're not talking about a handful of launches, but thousands, enough to build a sustainable presence on another planet. The Block 3 booster is the engine of that dream, the workhorse that will make regular, reliable space travel possible for the first time in history. But it's not just about the hardware. Advanced computers, cutting-edge avionics, and smart manufacturing techniques are all key to making spaceflight as routine as air travel. While traditional aerospace companies build a handful of rockets each year, SpaceX is building a fleet, dozens, even hundreds ready to launch at a moment's notice. The future of humanity's reach into the cosmos depends on this new approach to rocket manufacturing. It's a shift as significant as the assembly line was for the automobile. In the heart of SpaceX's rocket factory, tomorrow is being built, one booster, one Starship, and one bold idea at a time. The path to the stars is paved with setbacks and sometimes explosions. Recently, a SpaceX test ship exploded during a cryogenic proof test. For outsiders, it looked like disaster. For engineers, it was data. Every failure is a learning opportunity. Testing to destruction reveals weak points before flight. Engineers analyze every detail: sensor data, footage, wreckage. Was it a weld, a design flaw, or unexpected material behavior? This rapid cycle, build, test, break, learn, drives SpaceX's innovation. Each lesson is built into the next vehicle. Progress in rocketry is born from the ashes of failure. These trials make the path to space safer for all. Rockets need launch pads, and SpaceX is building them at breakneck speed. At Starbase and Kennedy Space Center, new towers rise to support rapid launches. Robotic arms, Mechazilla, lift and catch boosters, enabling quick turnaround. No landing legs needed. Boosters are caught, refueled, and relaunched within hours. On-site propellant production speeds up the process. The entire launch site is an integrated machine. Mass production and rapid launch capability set SpaceX apart. This is more than a rocket. It's a transportation system for the solar system. The foundation for a new era of exploration is being built now. The space race is now global. While Boeing and SpaceX battle, China is quietly building a world-class space program. Their next goal, a robotic mission to Neptune, the most distant planet. This mission would push the limits of propulsion, autonomy, and science. It's a direct challenge to NASA's deep space dominance. China's ambitions now reach the outer solar system. The rise of China adds a new dimension to the competition and to the risks. The final frontier is more crowded and more contested than ever. The US military saw promise in reusable rockets for rapid global cargo delivery. The Rocket Cargo Vanguard program aimed to use Starship to deliver supplies anywhere in under an hour. The vision deploy aid or troops faster than any plane. But the program hit a roadblock, not technical but environmental. Noise, emissions, and unknown impacts on the atmosphere raised red flags. The pause highlights a new tension: progress versus planetary responsibility. We must balance ambition with stewardship. Even as we reach for the stars, our feet remain on Earth. The future demands hard choices. We stand at a crossroads. SpaceX, Boeing, and China are pushing boundaries, but consequences are mounting. The pause of rocket cargo over environmental concerns is a warning. Our technology is outpacing our understanding of its impact. Space is not a void to exploit without consequence. The challenge: progress versus preservation. Space debris is a growing threat. Collisions could cripple the satellites we rely on. Tens of thousands of new satellites raise the risk of orbital chaos. The new space war is about responsibility, not just speed. We must develop sustainable practices, debris removal, self-deorbiting satellites, and global agreements. The choices we make now will shape space as a frontier of opportunity or a junkyard. The future depends on wise decisions. The stakes are cosmic. The story of space is unfolding now, shaping our future. SpaceX and Boeing represent two visions: rapid expansion or secure methodical growth. The choices made today will echo for generations. Block 3 could lead to Mars settlements. Boeing's satellites could secure peace. China's Neptune mission could inspire a new era of exploration. But with power comes responsibility. Environmental and orbital challenges are real and urgent. The future of space is a shared future. Keep looking up. Our next chapter is being written now. The universe is waiting. How will we answer its call?